Good morning. This is Miss Billerbeck, and we're going to talk about standard form of a linear equation. So the standard form of a linear equation is in the form of ax plus by equals c. And this is where a, b, and c are real numbers and x and y are the variables. So let's look at how we might use a standard form equation. We're used to slope-intercept form, and we're used to, we've seen point-slope form now. So let's take a look at what standard form ax plus by equals c might be useful for. So if we have Hannah will spend $150 on music festival tickets, reserved seats are $25 and general admission tickets are $10. Can we represent the situation in a linear equation? So the standard form is a linear equation. There's no exponents, so that makes it linear. So the variables have an exponent of 1 actually, but not anything greater or less. So let's define the variables here as x equals the number of reserved seats and y is the number of general admission seats. So we know that the reserved seats are $25. So we're going to write $25 times the number of seats will give us the total amount of money for the reserved seats. Plus, and then the general admission is $10. So $10 a general admission seat times the number of general admission seats. And then our budget is $150. So we don't want to go over that. $150. So that would be a standard form equation. Now, if we wanted to take that one step further, which you don't necessarily have to, but you know me, I always like, well, let's take it a step further. So we are going to take 25x plus 10y equals 150, and we're going to divide it all by 5 because that has a common factor. Okay, you don't have to do this, but it just makes the equation a little easier to handle. So when we do that, this becomes our new standard form of the equation. Okay, so it's just a little easier to manipulate. So from there, we can figure out various ways we could make combinations of things that we could, buy. How many reserve seats? How many general admission seats? So let's see what kind of combinations we can come up with. So we can make an XY chart. All right. So we could have 0 general admission seats, or these are reserve seats. We could have 1, 2, 3, 4, 5, or 6. Okay, so we have a few options. So if we have 0 general admission seats, so 5 times 0, that's just 0, plus 2y equals 30. So then we know that this is 0 plus 2y equals 30. So we divide by 2, and we see we can get 15 general admission seats. So if I don't go big and get some reserve seats that are really nice, I can get 15 general admission seats. So 10 times 15 is $150. So even if I reduce this for easier use, it still means 15 times 10 is $150, which was our budget. Now let's take the same equation and try 1. So if we put one reserve ticket, so we're going to sit alone, and we don't know how many general admission tickets we can afford. So this is just going to be 5. So we're going to subtract 5 from both sides. So we have 2y equals 25. So we have a little problem because when we divide by 2, we have y equals 12.5 general admission tickets. Well, we can't buy half a ticket. So we've just found out that the only thing we can do is even numbers. This needs to be an even number, okay? Because otherwise it'll end in a 5 and we'll get an odd number and we'll have half a ticket, and we can't buy half a ticket. So this doesn't work out because it was 12.5. You couldn't do a half ticket. So that means this probably won't work out, and this probably won't work out. So it just cut a bunch of calculations down if we wanted to see various combinations. So now we could do 5 times 2 plus 2y equals 30. So this is 10 plus 2y equals 30. We subtract 10 from both sides, and we get 2y equals 20. Well, when we divide by 2, this is a good thing. We have y equals 10 general admission tickets. Okay, so 10 times 10 is 100. And 2 times 5, 2 times 25, which was the cost of the reserved, is 50. So 100 plus 50 gives us $150. So if we buy 2 reserve tickets, then we can buy 10 general admission tickets. Thank you. So if I have 5 and I put in 4 plus 2y equals 30, so this is 20 plus 2y equals 30. So now we're going to subtract 20 from both sides, and we get 2y equals 10. Divide by 2, and we can buy 5 general admission tickets. So that was so this would be 5. So 4 times $25 a reserve ticket is $100. 5 times 10 general admission tickets is $50. So that 100 plus 50 is 150 still. So isn't that interesting how this just keeps working out? So we have 5 times 6 reserve seats plus 2y equals 30. Well, this is 30 plus 2y equals 30. So when we subtract 30 from both sides, we get 2y equals 0. Well, you divide 0 by 2, you just get 0. So we have a 0 there. So we can get 6 reserve tickets for $25, and that is $150. So that's how we would work a real life problem. Now, doing a slope-intercept equation, we could have gone that way with this, but is that going to be any easier? So if I take this equation here, this general admission equation, and reserved and general admission equation, and that's in standard form, and we wanted to rewrite it to, so this is standard form. Now let's take a look at it as slope-intercept. So that would mean we move this over to the other side. We can't combine 5x and 30 because they're not like terms. This one has a variable, that's a constant. So we have 2y equals negative 5x plus 30. And then we have to divide by 2 because y needs to be by itself. Whoops, that's a 2. Y needs to be by itself, so we have y equals negative 5 halves x plus 15. Okay, so that's my y-intercept. So when x is 0, when I buy 0 reserved tickets, I can buy 15 general admission tickets times $10 is 150. Okay, so here's my slope-intercept, but here was my standard. So this is slope-intercept. Form. Okay, which one would be more beneficial for this? Well, we probably aren't going to buy all general admission, and we probably aren't going to buy all reserved. We're going to do some mixture. So the standard form would show the mixture of combinations a little better. So I would probably go with this one for this real life problem. All right, so let's look at this one. Okay, so if I have this graph here, I can make a little chart. When you have standard, it's best to make a little chart, so a little XY chart. So we do an X and we do a Y like that. Okay, I like always doing X is 0 and Y is 0. Is that just, it's easy. And we mustn't do a lot of hard things. Okay, so if X is 0, that's 3 times 0 minus 2y equals 9. Well, that just means I have to divide by negative 2 here and negative 2 here because that's just 0. So my y then becomes negative. This becomes 4.5. So I should make a little more space, eh? So let's do that. So negative 4.5. Okay, so now when y is 0, let's see what happens. Whoops. Okay, so we have 3x minus 2 times 0 equals 9. So that's a 0. So we have 3x equals 9. And divide by 3, well, that's x is 3. So we can put 3 right here. Okay, so that gives us 2 points. So we have when x is 0, y is negative 4.5, which is right here. When y is 0, x is 3. So that gives us a point here. So let's get one more point because I don't like half points. I like whole points. So let's try something. All right, so if I have x is 2, nope, that doesn't work. How about, we did x is 3. How about x is 6? Yes, x is 6. No, that doesn't work. How about x is 5? That'll work. Okay, so let's try x is 5. So we get a whole number there. Okay, so we have 3 times 5 minus 2y equals 9. So that gives us 15 minus 2y equals 9. So we subtract 15 on both sides, and that gives us negative 2y equals, and that becomes negative 6. So when we divide by negative 2, look at that. We get y equals 3. So that's a nice point. No half points. It's a good point. So we go to 5 right here and go up to 3, which is right here. And look at that. It's right in line. So then we get our straight edge and we make a nice line. Let's see if this works. Okay, so take that and make a line. All right. So, so that's a great way to do it, is to make a chart. You really only need 2 points to make a line, but sometimes it's good to have a checkpoint. All right, let's look at this one. This one, we lost a little something in translation here. Okay, whoops. So we have 5y right here. Okay. So we have, make our chart. We have an x and a y. So of course we're going to do a 0 like that and a 0 like that to see if we have easy solutions. So 4 times 0 plus 5y equals 10. So this is 0, and then we have 5y equals 10. We divide by 5, and we get y equals 2. So that was nice. It's a good point. Okay, so we've got 1. Now we try, we'll put that in, and you'll see my problem here. So we have 4x plus 5 times 0 equals 10. So this isn't going to be the perfect point I was hoping for. So we get 4x equals 10. We divide by 4, and we get x equals 5 halves, which is that 2.5. So we can plot those two. So I have x is 0, y is 2, y is 0, x is 2.5. Hey, look. Oh, that's 3. So right here, 2.5. All right, so now let's try a bigger number. So how about x is 5? So when x is 5, we have 4 times 5 plus 5y equals 10. So this is 20 plus 5y equals 10. And when I subtract the 20, I get 5y equals negative 10, which when I divide by negative 5 on both sides, I get y equals negative 2. So let's see what that looks like. So at 5, I'm at negative 2. And look at that. It looks perfectly in line with the other 2 points. So let's graph that. Okay, so we have a really nice looking line there for both of them. So that is how we would use a little chart to keep track of what we're doing when we're using standard form. Okay, and always try the 2 zeros. They're easy. Don't work too hard. Okay. All right, next we have this type of graph. Okay, well, this one is in standard form, but let's actually just divide that 3 out. Let me use a different pen here. And let's see what we have. So this ends up, once we reduce this, y is negative 6. So that means y is negative 6 right here, and y is negative 6 right here, and right here. It's just always negative 6. So despite the fact that we want y to be vertical, it is not. It's a horizontal line. Okay, so it becomes y equals negative 6 like this. And it's just counterintuitive, but that is y equals negative 6. Okay, and I know it's counterintuitive. So we divide by 4 here, and this becomes x equals 3. So we go to x is 3 right here because we know that's a point, because that's the x-axis right there. So x is 3 here, x is 3 here. So just x is always 3. So when we graph this one, it looks like this. Okay. So we have y is negative 6, and then this, I guess I should have moved this over and planned better, huh? So y equals negative 6, and then this one is x equals 3. Okay, so that's how we would graph that. And believe me, these are counterintuitive. They'll be on most assessments because, well, everybody wants to plot them the other way. So we want to make sure you don't. All right? So that's just the simple matter of trying to get it through your head that the y equals 6 is horizontal, x equals 3 is vertical. Okay? All right. So our last example is going to be about going to the grocery store, and we have $60 to spend on a mixture of almonds and cashews. Okay, perhaps there's a party and we need to have them. Okay, so our almonds are $8 per pound and cashews are $10 a pound. So we're going to use variables A for almonds, the number of almonds, and number of pounds of almonds, and C is the number of pounds of cashews. Okay, so almonds again are $8, so let's keep track of that. So $8 a pound for almonds times the number of pounds of almonds plus $10 a pound for cashews times the number of pounds for cashews equals $60 because that's all we have to spend. So the question is, how many pounds can she buy if she only buys almonds or cashews? So we could go ahead and reduce this or leave it as is, but usually working with 10 and 60 shouldn't be too hard. So let's go ahead and do a little chart like this. So we have X, Y. So we want to, if we're only buying, oops, this is not X and Y, it is A and C. Okay, because those are our variables, A and C. So if we have 0 pounds of cashews, let's figure out how many pounds of, or 0 pounds of almonds, how many pounds of cashews. So that'd be 8 times 0 plus 10C equals 60. We have 0, and that's 10C equals 60. We divide by 10, and we get cashews is 6 pounds. So we get 6 pounds of cashews. That's pretty nice. Cashews. I like cashews a lot. But I love almonds too because it's what we grow in California. Okay, so then it asks, well, what about if you only buy cashews? So, that's only if you buy cashews. Now, if we only buy almonds, we zero out the cashews. Okay, so this time we have 8a plus 10, and we don't have any cashews, so we're going to zero out the cashews, and that equals 60. So we end up with 8a plus 0 equals 60. We divide by 8, and we have a equals, and then that becomes 7, because 7 times 8 is 56, leaving us 4 behind. So 4/8 is a half. So 7.5 pounds, because 0.5 is how we say half in decimals. So that's 7.5 pounds of almonds if we don't buy any cashews. And that makes sense because almonds are less, so we can buy more pounds. But what if we were to buy a mixture? So let's look at, well, what if we bought 5 pounds of almonds? How many pounds of cashews could we buy? So 8 times 5 plus 10c equals 60. So that's 40 plus 10c equals 60. Okay. And then we have, we subtract 40 from both sides, and we get 10c equals 20. So divide by 10, and we get the cashews equals 2 pounds. So if we have 5 pounds of almonds, we can buy 2 pounds of cashews. Okay, so if we wanted an even mixture, then we could, where A equals C, then we can substitute this in to find out, okay, if A equals C, that means 8A plus 10A equals 60. So we have 18A equals 60. Divide by 18. And A then is going to be, let's see, there's 3 A's give me 48. So 3 is not 48, it is 54 and 6/8. So let's do that really quick here. So 16, so we have 3, so that's 24, which is 54. And we have 6 left over. So 6/18 is 1/3. So 3 1/3 pounds of almonds and 3 1/3 pounds of cashews if we wanted an even mixture. Okay, so so that's it with the real life problem. Okay, so let's look at Desmos really quickly. Let's see if I can share here. Well, I was hoping to share. Let's see if I can get my mouse to work again. There we go. Here we go. All right, so we're going to look at slopes on the line. So far we've talked about the slope-intercept form, okay, which is y equals mx plus b. So B is just our y-intercept. So if it was down at 0, it would go straight through the origin, and that's with the slope of 1. So all the y-intercept does is it just moves it up and down, and the slope stays the same. Okay, so let's take a look at slope and depth. So if we looked at how slope works as we go positive, whoops, that's not quite 0. I wanted it right at 0. Oh, go back to 0. There we go. Okay, so if I go move this to a larger number, see how it gets closer to the y-axis, and it's very, very steep climb. But as x increases, y increases, and that's a positive slope. So when we have a slope of 0, of course, it's just flat. There's no cars rolling on that slope unless you push it. Okay, so then negative slope, as x increases, y decreases. And it again gets very steep as our numbers climb above 1. Okay, but if we go to 1, we have we have a really nice rise run. So like a nice little stair step. So negative 1 and 1 have a really nice little slope there. So you should be able to look at it and see the slope of 1, where it's a nice rise 1, run 1, rise 1, run 1. Okay, so we also have talked about point slope form. So let's take a look at that. So point slope form, we have y minus y1 equals m times x minus x1. So these are just different points here. So as my x, so if you see I have x1 right there, this is slope again. So all the slope does is it just changes it, but it changes it from that point now. Okay, not the origin. So if I change this point over here to 3, let's get it right at 3, and then make this 3 negative 3, and then I change my slope from 0, everything rotates from that point. So that's why we pick the point first, and then we draw the line from that. Okay, so that's the difference of point slope. You pick the point, and then you draw a slope from that point. And versus the slope intercept is similar. You pick the y-intercept. You pick this y-intercept, and then you can draw the slope from that. Okay? That's a subtle difference. The point slope means it doesn't have to be the y-intercept. Slope intercept, it is the y-intercept. So the last form of the equations that you just learned were standard form. So let's see how things react with standard form. So we have ax plus by equals c. Well, let's say we know what a is. Okay, so a is 4, and let's say b is 5, and c is what it all equals. Well, look at that. So it's just moving it at a certain angle from the point when we change that c. So it changes the combinations of what a and c would be. So now we have a point that's right here that looks somewhat viable, maybe a little point right here. Okay, so this one's a little harder to plot. So that's why I suggested that we use the table of the values, where you just have x and y and you choose a few points. Because you can see this one it's just not that easy to plot. Okay, but it is a useful formula for things like the theater tickets, where you might have certain combinations that you want and you have a certain budget you have to meet. So that's where this standard form really shines. Okay, but it is a little harder to plot. All right, so that's it for this lesson. That was lesson 2.3. And let's see if I can get back here. So there we go. So that's lesson 2.3. So I hope that answers most of your questions. Have a wonderful day. Bye-bye.